Let's solve this question. So here we have been given a signal x of t, that is a continuous time signal, and its Laplace transform is given as such. Then if x of t is this plus x3 of t, which is like a function of x of t only, which is a function of time, for t greater than or equals to 0, then the value of x3 of t will be what? So basically what they are asking is, if you find the Laplace inverse, you will get a time domain expression, and out of that time domain expression, two things will be common, and the third part will be uncommon, that will be equals to your x3 of t. Okay, so first what should be your observation is that this, right, is a complex root. Whenever this is a complex root, that means either you will get a sinusoid or a cosinusoid. Okay, so and you don't go for partial fraction. Whenever you see complex root, you say no to partial fraction. Partial fraction is no. Okay, then how should you proceed in this question? So two formula you know, right, for Laplace transforms. If you don't know, you have to go into my you search control systems by PrepFusion, and then you have to watch the basics of control system, the chapter 1. Okay, so there you can go and watch what is the Laplace transform of s square s over s square plus a square and Laplace inverse. Just hold on. Laplace inverse of s square over s by a square plus a square is simply cos of et. Okay, and Laplace inverse of a by s square plus a square is simply sine of et. Okay, so these two are the Laplace transforms. Now what they have given us, they have given us this function, right? So I will write it down. My x of s equals to s into s plus 5 into s square plus 16. Now there is a shortcut. What is the shortcut? First of all, this seems a bit difficult, right? This is not my standard format. So what I will do is I will convert this back to my standard format. One thing I know, that if I write my y of s, if I write my x of s as s times r of s, in time domain what it will be? In time domain I can use the property that my x t will be simply the differentiation of the time domain function of r of t, correct? So exactly same thing I will do. This s is multiplied with this whole function, right? So I'll write this as my r of t, not r of t, sorry, r of s, and then I will solve for this. So how will I solve? What is my r of s? R of s is s by s square plus 16 plus, I can write this 5 by 4 into 4 by s square plus 16. Okay, now if I take the Laplace inverse of this, what will I get? So now if I take the Laplace inverse of this will be simply cos of 40 plus cos of 40 plus 5 by 4 into sine of 40. This is my r of t. But what is my x of t? X of t is r dash of t. So my x of t is r dash of t. So it will be minus 4 sine 40 plus 5 cos 40. But you missed, like from here to here, that is where we do the mistake. What is the mistake? You forgot to write a u of t here. There was a u of t as well, correct? There was a u of t as well. That is where we forgot to write. So this portion is correct, but whenever there is a function a times b and then I am doing the differentiation, first I will differentiate this, I will write the other one as it is. So I will write this one as it is, and then I will differentiate the second term and write the other term as it is. So the second term will be this will be only same only cos 4t plus 5 by 4 sin 4t into delta of t. Differentiation of unit step is impulse. So whenever the impulse is multiplied, right, the time where the impulse is occurring, we put the value of t here, right? Reasons, all those things have been explained in control system, and I hope you have studied signals as well and you know this. So I have to put this t equals to 0 in this equation. I have to put t equals to 0 here. So if I put t equals to 0, overall my x of t, right, will come out to be 4 sin 4t plus 5 cos 4t u of t plus this will be 1, this will be simply 0, correct? Okay, this is not 5 by 4, sorry. Yeah, this will be 5 by 4, this will be simply 0. So it will be simply delta of t. That will be your final answer here. Okay, just hold on, I will check if everything is correct or not. First I differentiate this, yes, then I keep this one as it is and write the other one. Yes, it is correct. So it will be delta of t. So your answer will be here, option A, delta of t. So like a delta of t term will come at the starting as the x3, because other terms are fixed, right? Minus 4 sin t, minus 4 minus sin t, and okay, this minus should be inside here. Yeah, and this is plus 5 cos 4t, plus 5 cos 4t, and the other term, right, x3, that is simply your impulse, delta of t. Okay, so when you try to solve it, it will be very easy because you will not explain everything, but I have to explain, that's why it took me time. But I don't think it will take you much time to solve this question. This was a pretty simple question. Option A will be the correct answer for this particular question. Now let's solve this next question. This question is pretty interesting. We have to find out what does the negative feedback do. Negative feedback in a closed loop system does not reduce overall gain, does not reduce bandwidth, does not improve disturbance reflection, does not reduce sensitivity to parameter variation h. Okay, so for us to solve this question, right, what we can do is write this thing down. Okay, if I have a simple system that is simply a G, this is my input, this is my output, this is an open loop system. Now in this open loop system, if I add a negative feedback, what will happen? So if I add a negative feedback, first thing what we know is, we already know the formula of gain. Okay, or my transfer function becomes, previously my transfer function t1 of s, it was simply g of s, and here my t2 of s will be simply g of s divided by 1 plus g of s into h of s. So obviously the transfer function t2 of s will always be somewhat lower than t1 of s. It will always be the case. Okay, so overall gain will reduce. So the statement 1 is saying it does not reduce overall gain, which is incorrect. It actually reduces the overall gain. It improves the disturbance reflection, or it reduces the sensitivity variation. So if you find out the sensitivity, right, with respect to h, with respect to the open loop parameter g of the whole transfer function, in the case 2, you will see the sensitivity will be much lower than the case 1. Okay, you can find out, you know how to find out sensitivity, all these things you know. Okay, so obviously it reduces the sensitivity. That was the main reason for us to use a unity feedback. That was the reason for us to use a feedback system to reduce the sensitivity dependence on this transfer function g, right? If there is some variation in this g, this should not vary our output. That was the main reason for using the closed loop system, negative feedback. So obviously it does not reduce the sensitivity. Yes, it does reduce the sensitivity. But they're telling me it does not reduce the sensitivity. That is wrong, right? It does reduce the sensitivity. It improves the deflection, disturbance reflection. It does improve the disturbance reflection. If you want to know more about this, check out our full course that is on control systems. Okay, you can search on YouTube, control systems by PrepFusion. Now, does it reduce the bandwidth? So let me take an example. Here, my g of s is s tau plus 1. What is the bandwidth? Bandwidth is simply tau, right? This value. Because what is the pole zero diagram? Pole zero diagram is minus 1 by tau. Bandwidth is basically the inverse of the time constant, right? Or it is simply the pole. For a first order system, it is the pole itself. So it will be the magnitude of the pole, that is 1 by tau. But in the second case, my g of s is same, right? G of s is same. That is 1 by s tau plus 1. But what am I interested in? As it is a negative feedback system, assumption is h is 1. Okay, assumption is h is 1. So my transfer function now will change. Previously my transfer function was equals to g of s. Now my transfer function is 1 by s tau plus 2. So here what do I observe? Here I observe that the pole has now shifted more towards the left, that is minus 2 upon tau. What is the bandwidth? Bandwidth will simply be the magnitude of the pole. So it is simply 2 upon tau. So bandwidth has increased from the previous case. Just take an example. So this, right, this option that it is telling me that negative feedback does not reduce bandwidth. Yes, it does not reduce bandwidth. It increases bandwidth. So this option is correct. It increases the bandwidth. So this option B will be the correct answer of this question. If you have any more doubts, as I told you earlier as well, that you can go and visit the YouTube channel of PrepFusion and then search control systems by PrepFusion. These concepts will be clear in the chapter 1. Let's solve this question. The step response of LTI system is given as this. The transfer function of the system is given by what? Okay. So what will be the transfer function of the system if the step response is given as this? So what we know, the output is this, right? This is the step response. So we know that the response C of S is equals to transfer function of the system into input R of S, correct? And they're telling me for a step response. So if the input R of t is unit step U of t, then R of S will be 1 by S. And if it is a step response and my response is given in time domain, C of t is given. So what will be my transfer function? Transfer function T of S will simply be C of S divided by what? R of S. R of S is 1 by S. So it will be simply 1 by S. So S times this. So, but what is C of S? C of t is this, right? So what will be C of S? C of S I can directly write. This is just like valid for t greater than 0. So this is like a unit step function only. So it will be 1 by S minus, remember, like this is a bit lengthy. Okay, I will write here first. So this is not C of S. They are writing in terms of Y. So I will write in terms of Y only. So this will be Y, this will be capital Y. What is my Y of t? Y of t is 1 minus e raised to power 1 minus e raised to power minus 5t, 1 minus e raised to power minus 5t cos of 60 plus 5 by 6 sine 60. Okay, so this is multiplied by u of t as well. Okay, so if I take the Laplace transform of this, it will be 1 by s minus the Laplace transform of this multiplied by exponential. Exponential, what will it just do? It will just change the s to s plus 5. This exponential will just change whatever I will get to s plus 5. Whatever the Laplace transform of this I will get, the s will be changed to s plus 5. That is the only thing that will different that will this exponential do. Okay, so what is the Laplace transform of cos 60? If you tend to forget this, you can always remember that differentiation of sine is cos. So when I differentiate ddt of sine t, I get cos. So in Laplace transform, it will be s into Laplace transform of sine t will be equals to cos. So the cos t will have always s in the numerator and sine t will not have any s in the numerator. That's how you can remember. I know you get confused between which one is the Laplace transform of cos t and sine t. So cos will always have s in the numerator. So this will be s divided by s square plus omega naught square, that is this value, right? That is 6 square plus omega naught, that is this, and 5 by 6 is obviously here, into omega naught, that is 6 divided by s square plus 6 square. Now don't forget, I have to change the s to s plus 5 due to this exponential that is been multiplied. So the Laplace transform of this is this, but this is not exactly the Laplace transform if exponential is multiplied. So I will change my s to s plus 5. divided by s plus 5 whole square plus 6 square plus 5 divided by s plus 5 whole square plus 6 square. So now my transfer function will be just s multiplied by this y of s, right? So s t of s will be s multiplied by this y of s. So it will be 1 minus 1 minus s will get multiplied here, right? If s is getting multiplied, this ultimately will become s square plus 10s divided by s plus 5 whole square plus 6 square. Okay, so this is what I'm getting if s is getting multiplied. Okay, so can I write my transfer function? So my transfer function will be 1 is getting subtracted here, so it will be s plus 5 whole square. So it will be s square plus 10s plus 25 minus s square plus 10s divided by s plus 5 whole square plus 6 square. So ultimately this s square plus 10s gets cancelled, only 25 is left at the top. Okay, am I missing? Yes, I am missing another thing as well. This is there plus 6 square, right? I should have written here plus 6 square. This also was there. So it will be 25 plus 36, which is 61. 61 divided by s plus 5 whole square plus 6 square. Okay, they have not written in terms of that, also I will write it better. This will be simply 61 divided by s square plus 10s plus 61. Okay, so 61 divided by s square plus 10s plus 61, option D will be the correct answer of this question. You could have solved this in a different manner as well. Another information that you should know is that your step response, okay, your step response y of t is always equals to your what do you call, s is getting 1 by s is getting multiplied, right? So it is basically integration of your impulse response h of t, but impulse response is not given here. They have just given me the step response. So like, or you can write your impulse response, right? Impulse response h of t, this is from 0 to t, will always be equals to dy, the differentiation of the step response. Okay, like this also you could have solved in the time domain. If they would have asked expression in the time domain, I would have solved in the time domain, but here they have the options are framed in the Laplace domain, so I solved it in the Laplace domain. So option D will be the correct answer for this question. Let's solve this question. The network N is shown below, is supplied with a unit step current. If response V of t is given as this is a voltage response, right? This is the voltage across the current source. Then the network N contains what? A resistor with inductor, a resistor with inductor in parallel series, or a resistor with capacitor. Okay, parallel series. So first of all, we have to see what kind of input I'm getting. I'm giving a unit step input. So first of all, I have to identify what type of circuit is this. Is this a RC circuit or a RL circuit? Okay, what are the possible options here? So I'm giving a unit step input. So I will write down all the possibilities, right? I will draw all the possibilities. There are 4 possibilities. One is they're telling me a unit step input with a RL circuit. Okay, unit step input with a RL circuit. If I am giving a unit step input with a RL circuit, is it possible to get a response like this exponential? Actually, it is not possible. Why it is not possible? Because at t equal to 0, initially the inductor was uncharged, 1 ampere current is flowing. Then what will happen? An impulse, it will give a impulse response. It will give a impulse voltage as a response, right? But here, right, no impulse voltage is present. So obviously this option is automatically eliminated. Let's check the other option. Other option will be also same. That is the parallel circuit, right? RL parallel circuit. So here I have resistor. Okay, now this one will not be actually same. This one will be different. So initially inductor doesn't have any current. So it will behave as open circuit. Okay, so if it behaves as open circuit, all the current flows through the resistor. If all the current flows through the resistor, then the value of the drop initially at V of 0 will be simply R. But what is the case here? If I put T equal to 0, my voltage is 0. So this circuit is also eliminated. Let's check the third one with a capacitor and resistor in parallel with each other. So if I have a capacitor and resistor in parallel, so this will be R, this will be C. Okay, this will be R, this will be C. So now if at T equal to 0, what will happen? This will behave as a short circuit because the voltage was initially 0. If the voltage was 0, this will behave as a short circuit and all of the current will flow through this. Is there any problem? No problem is there. Can the voltage be 0? Yes, the voltage can be 0. So voltage will be 0 at T equal to 0, which is correct. At T equal to 0, voltage is 0. At T equals to infinity, the voltage is simply 1. At T equals to infinity, if I put T equals to infinity, this will be open circuit. All of the current will flow through this resistor, right? If all the current flows through this resistor, the V of 0 here is 0, V of infinity here is R. The voltage drop is R. Where they're telling me R is 1, so if R is 1, voltage will be 1 volt. So answer option C will be correct. You can check for the third option as well. It will be a series RC circuit. In a series RC circuit, it is not possible. Voltage will be linearly increasing because I am applying a constant current across a capacitor. Okay, so obviously voltage will be just linearly increasing, right? Voltage will be linearly increasing. You already know all this, that if I apply a constant current across a capacitor, voltage linearly increases. Okay, so this will not be possible. So option C will be the correct answer of this question. Let's solve this question. The block diagram of a control system is shown. G of s is given, H of s is given. The sensitivity of a closed loop transfer function with respect to G is alpha. Sensitivity with respect to H of that same transfer function is beta. For omega equals to 1 radian per second, then alpha plus beta will be. So I just have to find out the sensitivity with respect to G, that is open loop transfer function, that will be equals to alpha, and sensitivity of transfer function with respect to H, that is with respect to the feedback, that will be equals to beta. Okay, so obviously I can directly find this out. Very easy, right? Very simple. First of all, let me write this down first. So what is the sensitivity with respect to G? It will be simply del tau by del T divided by del G by G, or it is simply G divided by T into del T divided by del G. Okay, so this, right? What is my T? What is my T? T is G upon 1 plus G of H. G upon 1 plus G of H. Okay, that is what my transfer function T is. Okay, G upon 1 plus G of H. So it will be G upon T into del T by del G. Del T by del G, it will be, if I just compute the differentiation with respect to G, this will be 1 plus G of H whole square. This will be 1 plus G of H minus, this will be GH. So it will be, ultimately it will come out to be G upon T. Okay, G upon T into 1 by 1 plus G of H whole square. So this, right? What is T? T is also G upon 1 plus G of H. So G gets cancelled. This also gets cancelled. Ultimately, I am getting 1 plus G of H. Okay, I'm just replace my T with 1 plus 1 by G of H. Okay, so now I will put the S value. Okay, in terms of S, what is it? So G of H of S is 10 by S into S plus 1. So this ultimately becomes, so S into S plus 1 divided by S into S plus 1 in plus 10. Okay, this is what this becomes. Now I can write this as, I can replace S with J omega. This will be J omega into J omega plus 1 divided by J omega into J omega plus 1 plus 10. Actually, this is meant is that this is the magnitude. Okay, I should have mentioned here, this is the magnitude. This alpha and beta are the magnitude of the sensitivity. So if I want to compute the so alpha will be equals to what? The magnitude of this transfer function at omega equals to 2. So this comes out to be 2 into 2 square plus 1 whole under root divided by, okay, this, right? This, can we rewrite this? Okay, let's just hold on a second. Divided by, this will be minus omega square. So 10 minus omega square plus j omega. So this basically becomes 10 minus omega is 2, 10 minus 2 square is 4. This whole square plus 2 square, okay, whole under root. So this will be equals to 2 into under root of 5 divided by 6 square, that is 36 plus 2, that is 40. Okay, so this is 40 whole under root. So ultimately what this comes out to be equals to is, this is also 2 under root 10. So this comes out to be under root 1 by 2. Okay, this is what this comes out, right? Yes, 4 into 10, yeah, under root 1 by 2. This is all ultimately 5 there, so it is 5 here. Under root 1 by 2 is 0.707. okay, so you got your alpha. Now what about your beta? How do you solve your beta? So your beta will be equals to, if I want to find out your our beta, right? Sorry, here, right? Sorry, one mistake I made. At omega equals to 1, I have to find out. So if omega equals to 1, right? So all this is wrong actually. This will be 1 square minus 1. This will be 1 square. So this will be under root 2. Okay. And this will be 9 square, 81 plus 2, that is 82. So that is what I was thinking, what mistake am I making. So this will be 2 divided by under root 41. So 2 divided by under root 41, right? What will this come out to be? 41 under root into 2. It comes out to be 0.6 something. Okay. Sorry, this also will be 1, right? Sorry. This also will be 1, right? Sorry. This also will be 1. So it comes out to be 0.156. This will be your alpha. Okay. What about your beta? For beta, right, first of all I have to write down the sensitivity of the transfer function with respect to h. So what is it? It is again del t by t divided by del h by h. So it is h divided by t into del t by del h. So h divided by p into del t by del h. It is simply equals to, again, this will be 1 plus g of h of s whole squared into the differentiation of the upper one, that will 0 minus the differentiation with respect to h, differentiation with respect to h, differentiation with respect to h will be g, and obviously a g was already there, minus g square. Okay, g was already there, and yeah. So what is t? T is g upon 1 plus g of h. Okay, t is g upon g of upon 1 plus h of x. This will be g upon 1 plus g will get cancelled, 1g will get cancelled. Just I will write this down. So ultimately it will be gh minus of gh divided by 1 plus gh. So you will observe that there is a variation. If h varies, right, my sensitivity will vary by a large amount. Okay, so now we'll write this in terms of s. So it is simply equals to g into h, right? So g into h, this will come out to be 10 minus of 10 divided by s into s plus 1 plus 10. Okay, this will be your sensitivity. I will replace s with j omega. If I replace s with j omega, this will be minus 10. This will be j omega plus 1 plus 10. So this will come out to be minus j omega minus of omega square 10 minus of omega square. Again I will calculate at my sensitivity of transfer function, that is beta, at with respect to h at omega equals to 1. I will just calculate the magnitude because they are asking the magnitude. So it will be 10 divided by omega square plus 10 square. So it will be omega square, so 10 minus 1 square whole square plus 1 square whole under root. So it comes out to be 10. So you can observe, like this also I have explained previously as well, you can observe how greater is the sensitivity with respect to the sensor parameter h than the planned parameter k or g. Okay, so this will be 9 square plus 1 square, again that is 82 under root 82. So you will see it is 5 times more than that, right? So it is 5 times more than my previous value. So this comes out to be 1.1. Okay, now what answer we have to find out? We have to find out this alpha plus beta. This is my answer, right? Alpha plus beta is my answer. So alpha plus beta is my answer. So 1.1 plus 0.26 something like that, right? What is was 0.156 plus 0.156 is equals to 1.26 is equals to 1.26. So this will be your answer of the question. Let's solve this question. So here we have to find out the value of P if both of the figures represent the same system. What does it mean basically? If they are representing the same system, that means my ratio of x2 of s by x1 of s should be same. That is, the transfer function obtained from the system 1 should be same as transfer function obtained from the system 2. So if this is my t2 of s and this is my t1 of s, both of them should be exactly same. So my t1 of s should be equals to my t2 of s. Okay, so here what I can say is there are two ways to go about this. One is using Mason's gain formula, using Mason's gain formula. Okay, so this method is pretty simple, right? You know the Mason's gain formula, you find out the transfer function and you compare the transfer function and you can find it out. I will solve it using the second method, that is basics. This first one you will anyways know, first method. So this method you may not be knowing, so you will learn something new. So we'll assume this node to be A, this node to be B, this node to be C. Okay, so what are the incoming values that is incoming to XA, right? This node A. So my XA incoming things are 0.5 into x1 of s into minus of s inverse into XA itself. It is a self-resonating loop. So 0.5 into x1 of s minus s inverse into XA of s itself. So this will be XA of s equals to 0.5 into x1 of s divided by s 1 plus s inverse. Okay, this is my XA. Now what is my XB actually? So what are the incoming values? XA is incoming to this and XB itself is incoming, nothing else is incoming. So XB of s is equals to 2 times XA of s plus, not plus, sorry, minus P into XB of s itself. So my XB of s is equals to 2 times XA of s divided by 1 plus P. Okay, what about the C? My C, only one thing, okay, two things are incoming, again this minus s inverse and 4. So my XC of s, if you derive this simply, this will be 4 times XB of s divided by 1 plus S inverse. Same thing only, just 4 will be here because here was a 4, right? Here I had a 4. Okay, everything is similar only. And what is this x2? Finally I have to find out x2, right? What is x2? x2 is simply x2 of s is simply x2 of s is simply this xc of s. x2 of s is simply this xc of s. Okay, this is what my x2 of s is. Now this xc of s is equals to what? This is equals to 2 times not 4 times 1 by s inverse into xb of s. What is xb of s? Xb of s is 2 times 1 plus p into xa of s. What is xa of s? Xa of s is 0.5 into 0.5 into 1 plus s inverse into x1 of s. Okay, now finally I get back my ratio. So x2 upon x1 of s, this should be equals to what? So this will be 4 divided by 1 plus, so I will multiply this with s. That will be simple for me because this is also not in s inverse format, right? Okay, so this will be s plus 1 into 2 divided by, okay, 2 is gone anyways, 1 plus p into s divided by s plus 1. So this will be equals to 4 s square divided by s square plus s plus 1 whole square into 1 plus p. Now what I observe here is this is equals to what? This is basically the form in the form of s plus 1 whole cube. So if I just have a s plus 1 here, right? If I just somehow have a s plus 1 here, that will be fine. But at the top as well, I need a cube. I have a square right now, I need a cube. So this thing, right? 1 by 1 plus p must be equals to s divided by s plus 1. So from here you can simply get your value of p, that is s inverse. So your p will be simply s inverse. So which option is correct? In our case, option B will be the correct answer. This is a like mediocre question, like medium level question, because you had to work here. You had to do a bit of digging. Okay, so your P will come out to be simply S inverse. Option B will be your correct answer. Let's solve this question. The signal flow graph of a control system is shown below. The transfer function of the system is given as C by R. The phase lag theta in radians provided by the control system at omega equals to 1 degree will be. So what is phase lag? Phase lag meaning the negative angle that the transfer function is providing at omega equals to 1 degree. So my transfer function will provide a phase lag. So it should be equals to, if it is providing phase lag, it should be equals to minus theta, correct? Because lag means the angle is negative. It is providing some lag. That means it is providing some negative angle at omega equals to 1 radian per second. Okay, at omega equals to 1 radian per second. So whatever I will find the transfer function, then I will calculate the angle at omega equals to 1 radian per second, and then I will compare with minus theta. Okay, I will compare with minus theta. Because why? Because it should provide a lag. Then only it will be a lagging angle, correct? So SFG is given. So simply I can use the Mason's gain formula. How many forward path loop I have? How many forward paths I have? This is one of the forward path. Other forward path is this one, right? Everything else is not a forward path. So first forward path, the gain of the forward path will be simply S inverse. What is the delta 1? Delta 1 of the forward path, it is 1 minus the sum of individual loops, removing this forward path. If I remove this forward path, right? If I remove this forward path, then basically what are the loops left? So the loops left is this one. So this has a gain of minus 2, right? This has a gain of minus 2 right here. This has a gain of minus 2. Okay, so the loop gains, right, will be equals to minus 2 by S inverse. So it will be, just hold on. minus 2 by S inverse, that is minus 2 by S, and minus 1 by S. Okay, then plus into the multiplication of the loop gains, into the multiplication of loop gains. Multiplication of loop gains is minus 1 by S into like multiplication of isolated loops. These two loops are totally isolated, so this will be minus 1 by S into minus 2 by S. So ultimately it will come out to be plus 2 by S. Okay, so my delta 1 comes out to be 1 plus 3 by S plus 2 by, this will be S square, 2 by S square. Okay, what about the second loop forward loop gain? So if I calculate the second forward loop gain, right, P2 is simply equals to S inverse. P2 is simply equals to S inverse. Delta 2 equals to 1 minus the sum of individual loop gains excluding this forward path, right? If I now exclude this forward path, okay, this is 2, this should be, so we'll mark it down. If I exclude this forward path, okay, if I exclude this forward path, then this will be like if I exclude this forward path, then how many loops are left? This is the loop that is left, and this loop was also left, right? This loop is left, and this loop is left. So again it will be minus 2 by S minus 2 by S. So it will be minus 2 by S minus 2 by S plus the multiplication of individual loops, that is minus 2 by S minus 2 by S. Both are isolated. Here I observe, though they don't have any nodes in common, both are totally isolated of each other, so they are non-touching. So it will be equals to 1 plus 4 by S plus 4 by S square. Okay, so I get my L1, L2, all those things. Now what is the delta? Delta is simply includes the all the loops. If I include all the loops now, then these three loops are there. These three are non-touching as well. So it will be minus 1 by S, minus 2 by S, minus 2 by S, and individually also they are non-touching. So it will be minus 2 by S into minus 2 by S plus minus 1 by S into minus 2 by S plus minus 1 by S into minus 2 by S. Are three loops non-touching? Are three loops non-touching? Yes, three loops are also there, that is non-touching. These three loops are non-touching. So generally this doesn't happen, but another term will get added here. This is the summation of two non-touching loops, then minus summation of three non-touching loops. How many three non-touching loops I have? One. Only one three non-touching loop I have, that is this L1, L2, L3. These three are all non-touching. So ultimately it will come out to be minus 2 by S into minus 2 by S into minus 2 by S. So not 2 by S, minus 1 by S. So this is very big. So my delta comes out to be minus 5 by S. This is plus 422. So this is 422. So it will be 8 by S square, then plus 4 by S cube. Okay, so this comes, now your transfer function C of S over R of S will simply be equals to P1 delta 1 plus P2 delta 2 divided by delta. Okay, so this will come out to be P1 is S inverse, right? P1 is 1 by S. P1 and P2 both are 1 by S. 1 by S into delta 1. Delta 1 is 1 plus 3 by S plus 2 by S square. 1 plus 3 by S plus 2 by S square. Okay, 1 plus 3 by S plus 2 by S square. Then plus 1 by S into 1 plus, this will be 4 by S, I believe. 4 by S plus 4 by S square. ultimately the denominator is 1 minus 5 by s. Okay, this will be plus, right? Okay, sorry, this will be plus, right? This will be plus, sorry. This will be plus 5 by s plus 8 by s square plus 4 by s cube. So I can multiply s cube both on numerator and denominator. So it will be s square plus 3s plus 2 plus s square plus 4s plus 4 divided by s cube plus 5s square plus 8s plus 4. Okay, so this will be equals to now we'll collect the like terms. So 2s square plus 7s plus 6 divided by s cube plus 5s square plus 8s plus 4. Now what do I need to find out? I need to find out the angle of transfer function t of j omega, replacing s with j omega, replacing s is equals to j2. Okay, so if I replace this with j omega, right? If I first of all replace s equal to j omega, first of all I will write this. So it will be 2 into minus of omega square, because j square is minus 1, plus 7 j omega plus 6 divided by minus of j omega whole cube minus 5 omega square plus 8 j omega plus 4. Now can you write down the angle of this thing? Okay, so this is equals to 6, this is the imaginary part, j omega 7 omega plus 6 minus 2 omega square divided by this will be the imaginary part will be j into 8 minus omega cube plus 4 minus 5 omega square. Now one thing you have to keep in mind, your omega, right, is equals to 1. Okay, so if your omega, like they are asking to find out the angle at omega equals to 1. So is at omega equals to 1, like this is a very good question. Okay, at omega equals to 1, what are the coordinate angles? So at omega equals to 1, this will become say plus say 7j 4 divided by this will be plus 7j minus 1. Okay, this will be minus 1. So just be careful here at which quadrant this point is lying, where x is negative and y is positive. If x is negative and y is positive, I am lying in the second quadrant. And what is the angle of the second quadrant? Okay, the angle, right, this is my theta, angle is 180 minus theta, because why? This is total 180 and I will subtract theta so that I will get my angle from the positive x-axis. What is theta? Theta is the mod of height upon mod of base, tan inverse of mod of height upon mod of base. So this is tan inverse of y upon x. Okay, so all this I have taught in my basics, I will not explain here. So the angle of t of j omega at omega equals to 1, this will provide positive angle, that is tan inverse 7 by 4 minus this, as this is in a denominator, it will be minus tan inverse. Now remember, this will be 180 minus theta. Okay, the denominator will be 180 minus theta, so it will be 180 degree minus theta, that is tan inverse mod of y upon x. So it is tan inverse mod of y, that is 7 upon 1. So now we will calculate the answer. Okay, now we will calculate the answer. 7 divided by 4 tan inverse 60 minus 180 plus tan inverse 7. So it comes out to be minus 37 minus 37.875 degrees. So it is providing a angle of minus 37.875 degrees. How much phase lag it is providing? Whenever the word phase lag is introduced, automatically the negative sign is taken care of. So it is providing a phase lag of 37.875 degrees, but they have asked us in radians. They have asked in radians. They have not asked in degrees. They are asking radians. So I will answer in radians, right? This is a very, very good question. So I have to convert this into radians. So if I convert this into radians, this will be my theta. My theta will be minus 0.66 radians. Okay. So I have to compare this with minus c, right? Minus theta lag. This was what I was supposed to find, because initially I have written that my angle is minus theta. So theta, that is a phase lag, will be equals to plus 0.66 radians. Theta, or the phase lag, will be equals to 0.66 radians. This will be the answer of this question. Let's solve this question. The block diagram of a control system is shown. The C by R, gain C by R will be equals to what? So whenever you have to find C by R and a block diagram is shown, right, you never solve using block diagram reduction techniques. You just solve using my method, whatever I will teach you. So what you have to do, first of all, you have to draw the block diagram. Step 1 is drawing the block diagram. Once you draw the block diagram, you just annotate on the block diagram what are each points equals to. So this point is equals to C, correct? This point is equals to C, and I'm multiplying minus 1 with this to get to C, right? So what should be this point equals to? This point will be equals to minus of C, correct? This point will be equals to minus of C, because multiplying minus 1 with minus of C should be get me C. What is this point equals to? This point should be equals to C by 3, because after multiplying with this block I should get C here, right? So this is equals to C by 3. That is fine. This is minus C. This is minus C, and this is what? This should be equals to plus C. Then this should be equals to plus C, and this should again be equals to minus of C. Okay. So minus of C and R are getting added here. So it will be R minus C, and I have a gain of one block. So this will be forwarded to R minus C only, and then R minus C is getting added with R plus C. So ultimately what will happen? This will become okay, sorry, one thing I missed here. Actually this, right, is output is getting taken out from here. Okay, now that is fine. This can be taken out from here. Only these two are getting added, right? These two are getting added. That is fine. Okay, so this is R minus C. So if I add here, R minus C is here, and plus C is getting added. Also this is also getting added, right? What is this? This is the output of this adder. This is the output of this adder. What is the output of this adder? R minus C. So here another R minus C is getting added. Another R minus C is getting added. So ultimately what will this become? This will become 2R minus C. This will become 2R minus C. Okay, I will explain this bit again. So I have a R here and I have minus C. So output of this block, let me name the output of the block as P. Okay. So whenever these kind of sign is there, right, that means I'm taking the output from the adder. So this output of the adder is P. This output is also P, because adder can have only a single output. So this output is getting added here and here. Okay. Here a plus sign should be there. A plus sign should be there. That is the mistake. Plus sign will be there. Okay. So this should get added here, and ultimately what will be the output of this? So three things are getting added: R minus C, again R minus C, plus C. So overall it should be output of this adder will be 2 minus C. Okay, then I'm multiplying 2 with it, so this will become 4 minus 4R minus 2C. Okay, 4R minus 2C. This is the output of this gain 2 block. Okay, and here minus C is getting added, again R minus C is getting added. So ultimately this will be what? This will be 4C minus 4C. Here I have 4C. Okay, and this is equals to what? This is equals to this is R. Okay, yeah, this is R minus C and 4. So how many R's I have? 1, 4, 5R. I have total of 5R. Total of 5R. I have 5 minus 4C. correct? Yes, 5 minus 4c. Now this is equals to my c by 3, right? Or you can understand like this also, this multiplied by this gain 3 block should be equals to c, correct? So I will write here, this is very small now, so my 5 r minus 4c into 3 should yield me c. So ultimately my 15r equals to 12 will go there, it will be 13c. So my c by r is equals to 13 by 15. So what is 13? Sorry, is it 13 by 15? No, it's the other way around, 15 by 13, correct? So it will be 15 divided by 13. So it is 1.154. This will be the answer of this question. Let's solve this question. We have to find out the number of two non-touching loops for the signal flow graph. Okay, so how many two non-touching loops are there? So I zoomed out the signal flow graph and you just have to count. That is just the procedure. So I see these loops are touching, right? So I will write here, let me name the loops. This is one of the loops, okay, L1, L2. This is this a loop? No, this is not a loop, right? This is not a loop. But if you observe it carefully, this is a loop actually, correct? This is a correct loop. So this is the bigger loop, that is L3. Now let me name this as L4. Again the same thing, this will be L5, this will be L5, this will be L6, this will be L7, the bigger loop, okay? And don't forget, this is also a loop, right? This is also a valid loop. This will be L8. So total I have 8 loops. Now you just need to count how many loops are non-touching. So I observe, obviously this L1 will be non-touching with all of these loops, right? So L1 has total, L1 is non-touching with all the other loops, that is L4, L5, L6, L7, L8. Same for L2 as well. Same for L2 as well. So L2 will also be non-touching. So total how many I had currently? So this combination 1, 2, 3, 4, 5 into 2. So 2 combinations. So total 10 combinations I have. Okay. Now for L3 will it be the same? For L3, okay, so, okay, one mistake I have made. Not for L2 actually. For L2, actually I made a mistake. This, right, L2 and L4 cannot be non-touching because this node is common between them. So L4 has to be removed. L4 has to be removed, right? So for L2, it will be L except L4 everything else. L5, L6, L7, L8. Okay. Now, what about L3? For L3 as well, it will be the same except L4 everything else. So for L3 as well, it will be the same. Okay. So it is 5 plus 4 plus 4. Okay. 5 plus 4 plus 4. 5 plus 4 plus 4. So it is 13 currently. Okay. What about L4 now? Now already these loops have been taken, right? These combinations have been taken. So I will not take it anymore because L4 is already with L1, and L2, L3 anyways it is touching. I will only take the right hand side. So on the right hand side I see L4 is non-touching with L6. Is it non-touching with L7? No, it is not touching. It is not non-touching with L7. It is non-touching with L8. It is non-touching with L8. So L4 is non-touching with L6. It is non-touching with L8. So L4 is non-touching with L6 and it is non-touching with L8. So plus 2 I will do, plus 2. Okay. This comes from here. This comes from here. This is this I should make a comma here, right? L2, L3. This also comes from here. And this one comes from here. What about L5 now? Already all these loops have been taken. Is L5 non-touching with any of the other loops? Yes. L8 is only the loop that is L5 is non-touching. All these loops have already taken, right? Here I can see L5 is already taken for L1. L5 is already taken for L2. So these are already taken. L5 is already taken for L3. These are already taken. L5 is non-touching with L8, only non-touching with L8 because it is common here with L6 and obviously it is common with L7 as well. So L5 is not common with L8. Okay, so plus 1 I will do, plus 1 I will do. Now what else is left? Is L6 uncommon with anything? L6, right? All the left hand side loops have been taken. Right hand side, this is a common with L8, this is common with L7. No. L8 is uncommon with anything? No. All the left hand side loop have been taken. So this is not uncommon with anything. L7 also same. So only these many loops which are non-touching. So it will totally become out to be equals to 16. Okay. So there are 16 pairs of loops which are non-touching. 16 pairs of loops that are non-touching or isolated, that are non-touching. So 16 will be your answer of this question. Let's solve this question. So we have to find out the number of 3 non-touching loops for the signal flow graph. This is a common data question. So I solved the number of 2 non-touching loops in the previous question. So now we'll solve the number of 3 non-touching loops. So how will you solve this? So again, I have named the loops. Okay, I have explained, like I have these many loops, right? This is L1, this is L2, and this is my L3. This is another loop, L3. Same way here I have L4, again my L5, L6, and this is my L7. Okay, and this loop is my L8. So these are my 8 loops total. So how many 3 non-touching loops are there? Again you have to count. So obviously if I choose L1, right? If I choose L1, obviously I cannot choose this L2, L3. These are gone. L4, yes, L4 is a non-touching combination. If I choose L4, what else is non-touching? I cannot choose L5, L7. I cannot choose L5, L7, but I can choose L6 or L8 because L1, L4, and L6 and L8 are all, or L6 or L8 are all non-touching. So what am I talking about? I'm talking about first I will choose L1, then I will choose L4, then out of L4, right? Then I can either choose L6 or L8. Both combinations are, all of them are isolated, all of them are non-touching with each other. Okay, either combinations are isolated and non-touching with each other. Anything else I can choose? If I choose L3, right? If I choose L3, then I can choose L5 and L8. Same for L2. If I choose L2, I can choose L5 and L8. Can I choose anything else? Can I choose L6? No, I cannot choose L6. So if I choose L2 or L3, I can choose L5 and L8. So if I choose L2 or L3, the other combinations will be fixed. That is L5 and L8. These are fixed. Okay. So total these two combinations. So currently I got 2 plus 2 combinations. Okay. Next, if I choose L4, right, I will not have any combination left because I have already chosen the previous 3. Out of these 3 I have chosen. So I can only look on the right hand side. If I look on the right hand side, I can choose L6. But I cannot choose any of this. I can choose here L1, but that combination L1, L4 and L6, that combination is already taken. I cannot choose L3, right? And L1, L4, L6 combination is already taken. L1, L4, L4, L8 combination is also taken. Okay. So 2 plus 2, any other combination if I can see. Okay. So this L8 is here. L8 is only, okay, L8 is already present over here only. So if I choose L4 can it be with anything else? No. If I choose L5, okay, L3 is here. Anything else? No, I cannot choose anything else. L5, L3 if I choose, right? L3 is already chosen, taken in the previous combination. Anything else? Okay, this L7 can be taken, right? I have never taken this L7 actually. Can this L7 be taken? If I choose this L7, okay, no, L7 cannot be taken actually. If I choose this L7, right? If I choose this L7, L2 can be taken, but what is the other loop that I can take? Other loop I cannot take. I cannot take any other loop. Okay, so L7. If I choose L6, L4 is already taken and L1, but this combination is already done, right? L1, L4, L6 combination is already done. L8, L5, L1. Okay, this combination is not done, right? L1, L5 and L8. Okay, I missed this combination. L1, L5 and L8. This combination is also left, right? So with L1, I missed this combination previously. With L1, I have L5, right? This is non-touching, and this L8 is also non-touching. Okay, so total, like this, I know this is a bit difficult, but you have to be patient with it here. So total number of combinations will be 2 plus 2 plus 1, that is 5. 5 will be your answer for this question. Let's solve this question. The signal flow graph of an electrical circuit is shown below. Okay, then which of the following options will be correct? So V1, all these are marked, and we have to identify which of the following options will be correct for A, B, C and X. Okay, so first of all, I write here, right? I1, I2, everything is written. So I'll write this in our KCL. I will write few KCL. No, not KCL. Sorry, I will write few KVL. I will apply the mesh law. Okay, if I apply the mesh law, okay, so because I want to write the equivalent equations, right? So I can write my VI is equals to this drop, that is I1. Let me mark down the impedance. Let me mark this as Z1 of S. Let me mark this as Z2 of S. Okay, just writing it Z1, Z2 for now, Z3 and Z4. Okay, later on I will change the values. So it will be Z1 into I1 of S, everything is a function of S, I will not write that, plus I1 minus I2, because here I1 is in this direction, I2 is in this direction, so it will be I1 minus I2 into Z2. This is my first equation, correct? So here am I getting any similar equation? Here my I1 of S equals to VI into A and minus X into I2, correct? That is what my I1 is equals to. So I can write the same thing here. I can write my I1 here. So what is my I1 here equals to? So I can write my I1, this if I take common, right? So this will be I1 into Z1 plus Z2 minus I2 Z2. This is my VI, so I can rewrite this like like this, that my I1 is equals to VI by Z1 plus Z2 minus I2 divided by Z2 divided by Z1 plus Z2. So if I compare these equations, sorry, this will not be minus, this will be plus. So if I compare these equations, I get my A is equals to 1 by Z1 plus Z2, and my X is equals to minus Z2 divided by Z1 plus Z2. So what was my Z1, Z2 initially? So my Z1 is 1 by CS, that is 1 by S. Z1 is 1 by S and Z2 is simply 1. Z2 is simply 1. So I can write here my Z1 is 1 by S, Z2 is simply 1. So my A, this will be 1 divided by 1 by S plus 1. So this is S divided by S plus 1. So A is S divided by S plus 1. What is my X equals to? X is equals to, this will also be the same only because it is Z2 is 1 only. So it will be minus of S divided by S plus 1. So I see A is equals to S divided by S plus 1, which is present in the option B, and C is also correct. X equals to minus S by S plus 1. Now I have to check for the other KVL, this KVL, right? The right hand side KVL. If I apply the right hand side KVL, I will get another equation. So it will be I2, I can write in terms of VO, but I don't need to write in terms of VO. I can directly write here, right? Can I directly write? Yes, I can directly write here, because they are only asking me about B. They are not asking me about C. So I will write only this equation. Which node are incoming to I2? The only node that is incoming to I2 is I1. So I2 is equals to I1 into B, correct? And I know what is I1 is equals to. Or like how can I write I2 and I1 here? How can I write I2 and I1 here? Yes, I can write I2 and I1 here. So if I write this, if I apply this KVL, right, without writing VO in terms of I1 and I2. So if I write the right hand side KVL, so it will be, I will start from here, it will be I2 into 1, okay, I2 into 1, that is I2 into Z4 plus I2 minus I1 into Z2. This is the value, right? I2 minus I1 Z2 into I2 into Z3 plus I2 into Z3 plus I2 into Z3. Okay, this is equals to 0. This is equals to 0. So my I2 is Z2 plus Z3 plus Z4 is equals to I1 into Z2. So ultimately my I2 is equals to Z2 divided by Z2 plus Z3 plus Z4. So this is equals to my B, right? So what is my, like, this is the relation that is written in the SFG. So what is my Z2, Z2, Z3 and Z4? So my Z2 is 1, Z2 is 1, Z3 is also, Z3 is S, I think. It is simply LS, L is 1, so it will be S. And Z4 is also 1, Z4 is also 1, okay. So it is 1 divided by S plus 2. So your B should be 1 divided by S plus 2, which is present in the last option. So your answer will be B, C, D. This will be your answer of the question. Let's solve this question. A system is shown below. R of S is 1 by S, 10 by S plus 10. Okay. If R of S is unit impulse input, rise time and settle time for the system will be. So you have to find out the rise time and settle time for a unit impulse. Okay. So let me first find out the output. What is the output actually? So output is basically my 10 by S into S plus 10 into R of S. That is my C of S, correct? But here, what is my C of S? C of S is simply 10 by S into S plus 10. Why? Because R of S is unit impulse, right? And the Laplace transform will be simply 1. So if I want to find out the C of t now, C of t will simply be, this will be 10, I can take common, this will be, if I put S equal to 0, right? This will be 1 by S. If I put minus 10, right? This will be minus, okay, if I put minus 10 here, it's 10 by S plus 10. So this will be your value, correct? So now if I want to take the Laplace inverse of this, what will I get? If I put S equal to 0 here, it will be, okay, 1 by 10. Okay, anyways 1 by 10 is here also. Okay, so anyway we get back our same result, that is 1 minus e raised to power minus 10t into u of t. Okay, so this is my value of C of t. So now what will be the what is the definition of a rise time? Always, you don't just remember the formula, you always mug up the formula, right? You don't remember the definition of a rise time. Rise time, the definition of rise time for a second order system was supposed to be from 10% to 90%. The time it for the this output response to go from 10% of its final value to 90%. That is the rise time. And what is the settling time? Settling time is simply, this is like a settling time is like 4 times tau, right? Because this exponential will settle in 4 times tau. So here settling time will be very simple, that is 4 times the tau, because this is just exponential. There is no second order thing over here, only one single exponential is here, correct? So this will be equals to, remember this, okay, everything is correct on, yeah, everything is fine. So this will be equals to, what is my tau? Tau is 1 by 10, right? So it will be 4 by 10. So it will be 0.4 seconds. So your settling time will be 0.4 seconds. Okay, so I can see they are asking me settling time, and these two options are actually matching. Settling time is okay, but I need to differentiate between the rise time. So first of all, I have to, what is a steady state value? What is the steady state value? So steady state value is simply 1, okay, because this goes to infinity, this goes to 0, right? T goes to infinity, this goes to 0. This is my steady state value. So 10% of this value, when do I reach at 10% of this value? So let's assume at T1 I reach 10% of this steady state value. So then I will equate this with e raised to power minus 10 T1. Okay, so from here I will be able to find out my T1. So what will be my T1? T1 will be 0.8. I will just quickly write the value of T1. Okay, calculate the T1. So it will be 0.9 ln divided by 10. Okay, so it will be 0.01. 0.0105 seconds. Okay, so this will be 0. And 90% I will reach 90% when, let's assume at T2, time T2. So this will be 1 minus e raised to power minus 10 T2. So what will be the value of T2 now? So T2 will be, this is 0.1 divided by 10. Okay, now first I have to do 0.1 and then I have to do ln, then divide by 10. So this will be 0.23 seconds. Okay, so now if I subtract, what is my T rise? T rise will be the duration once I reach 10% to 90%. Okay, so it will be T2 minus T1. So it will be 0.23 minus 0.0105. So it will be almost nearly equals to 0.22 seconds. So 0.22 is in the option C. So my option C will be correct, right? Just be careful about the definition. So if you are forgetting all this, you can go through our lectures, control systems by PrepFusion on YouTube. Let's solve this question. The unit impulse response of a second order system is given like this. We have to find out the value of A. So if you remember, you should always remember the standard unit step and unit impulse response of a second order system. Okay, so whenever there was a term exponential, right, this term used to come with this some exponential. What is it? It is basically minus zeta omega n. How do you remember this? You can remember this as the negative real part of the root. Negative real part of the root, because whatever exponential time constant is always on the real line, right? So it is the negative real part of the root. So that's why this is minus zeta omega n. And what is this? This is omega d into t plus theta. Correct? So omega d is 0.6. Theta is 36.86. So I can find out my zeta. Zeta will be equals to what? Zeta will be cos of theta. So it will be cos of 36.87 degree. So this will be equals to 0.8. Okay, this will be equals to 0.8. Okay, this is equals to 0.8. Now this value is equals to 0.8. Damping ratio I know 0.8, and my omega d is 0.6, right? So what will be my omega zeta omega n? So omega n is what? Omega n is basically omega d sine theta. If you remember something, not omega d sine theta, sorry. Omega d is equals to omega n sine theta. Few things if you remember, that's good. If you don't remember, that's fine. Otherwise also you can find. Okay, so your omega d, omega d is 0.6 divided by sine theta. Sine theta is 0.8. This is my omega n, correct? Or this is also equals, sorry, sine theta, right? So this is 0.8, sorry, this will be 0.6 only. Sine theta is 0.8, so this will be 1 only. So zeta omega n will be simply 0.8 only. So finally here, right, A will be 0.8. A will be equals to 0.8 only. This will be your answer. Let's solve this question. We have been given the unit step response of a unit feedback second order system. This is a standard second order system. We have to find out the delay time in seconds of this same system. So first of all, what is the delay time? if I know delay time is equals to, for a standard second order system, for a underdamped system, it is TD equals to 1 plus 0.7 7 zeta divided by omega n. How do you remember this? In my full course I told that if this is d, right, then you remember this as n. Okay, that's how you remember. If this was t rise, then I would have put omega d here at the bottom. And what was the formula? It is pi minus theta. What is theta? Theta is cos inverse zeta. Okay, so all these things you should interrelate and remember, put in your short notes. Now what is the standard second order system? Okay, response of a second order system. Standard second order system response is something like this: e raised to power minus zeta omega nt divided by 1 minus zeta square sine omega dt plus theta. Okay, this is the standard second order system. But what do I have here? Is this same? No, I have to convert this back into this format. How do I convert it back? I will explain how do I convert it back. So this I can simplify as 1 minus a e raised to power minus 4t. I can take common, right? From everything I can take common. Then this will be simply 4 sine omega t plus 3 cos omega t. Okay, now how do I convert this into single sign? If you know the formula, that's great. If you don't remember the formula, you can always take help of the phasor. Understand this thing: the cos is on the x-axis and sine will just be lag behind the cos by 90 degrees. Okay, next thing is, what is the magnitude of sine? Magnitude of sine is 4. So this is of 4 units. And what is the magnitude of cos? Magnitude of cos is 3. So this is of 3 units. So why like this? And my reference will be always sine. So I will draw a triangle. Okay, and the hypotenuse of the triangle will be 5 because it is Pythagoras, right? 3 square plus 4 square. The height, altitude of this triangle is 3. The base is 4. So what will be this angle theta? This angle theta will be, from the sine, it will be tan inverse 3 by 4. This is my angle theta, correct? So what is this value equals to? I will quickly calculate this. So 3 by 4 tan inverse, that is 36.87 degrees. Okay, so this equation can be converted into 1 minus a e raised to power minus 4t sine, like 5 also will be there actually, because its magnitude is 5 and the angle is like it is leading, so it will be plus, right? Because it is leading from sine, then it will be plus sine 36.87 degrees. Okay, so what is the zeta? Zeta is cos of this angle, right? Zeta is cos theta of this angle. So cos of 36.87 degrees, so it will be 0.8 basically. Okay, and I know this value is what? This is zeta minus zeta omega n. So zeta omega n is equals to 4. Okay, so omega n will be simply 5 radian per second. Okay, this is the value of omega n. So we got zeta omega n, we got everything. So now I will put this in the delay time expression. So what will be my delay time finally? Delay time will be 1 plus zeta into 0.7 divided by omega n 5. So now if I compute all this, right, into 0.7 plus 1 divided by 5, you get your result as 0.312 seconds. So this will be your answer of the question. Okay, so let's solve this question. So we have been given a block diagram and we have to find the sensitivity of the steady state error, okay, with respect to parameter alpha. So we have to find out S of ES of S with respect to alpha. So how do I find out this? For this to be found out, first I have to calculate the ES of S. Okay, So this is a non-unity feedback system, and for a non-unity feedback system, if you already don't know, you can go in the YouTube search non-unity feedback system steady state error by PrepFusion. Okay, else if you already know, here is the summary. Main summary is there will be error due to the non-idealities in the transfer function. How do I calculate? First, I assume that my output has reached reference. If my output has reached reference, that means the error will be 0. That means R of s minus C reference into H of s will be 0. Now, in the practical case, output will actually not reach the reference. It will be some actual value, that is R of s into the transfer function of all the whole block diagram. Because there is some error in the transfer function, that's why my actual C actual will not always be equals to C reference. So my error will be C reference minus C actual in the practical case. Okay, so all these things I know. I can directly write my ES as, right, steady state error will be S limit S tending to 0 S E of S, which is equals to this value, right, which is equals to S R of S by 1 by H of s minus 1 by H of s minus C reference of s. Okay, that is this is T of s. So I need to find out all these values. First of all, R of s is unit step, right? They have told me with respect to step input. That is fine. So I need to find out the transfer function. What is the transfer function? H of s is this, right? H of s is this simply. Transfer function will be K upon S into S plus 1 into S plus 4 plus K into S plus alpha. S plus alpha. Okay, this is my transfer function, and H of s is this. So can I put like here, what will happen? S and S will get cancelled, right? This will be 1 by S. Okay, and here I have limit as S tending to 0. So this 1 by S and S will get cancelled. Can I put here 0? Yes, because if I put here 0, right, I am not getting any undetermined format. It is simply alpha. Alpha is a constant. So this will be 1 by alpha minus T of 0. What is T of 0? T of 0, this will be gone. This will be 0. This will be K into alpha. K by K into alpha. So KK will get cancelled. This will be again 1 by alpha. So surprisingly, your steady state error comes out to be 0. Okay, it is not a function of alpha. Okay, it is 0. So the what will be the sensitivity of ES of S with respect to alpha? It will be simply D ES of S differentiation with respect to alpha into this value, right, into ES of S into alpha. But as your steady state error itself is 0, I cannot define it, right? Because here this S of S is 0, right? So something divided by 0, and this is also 0. This is getting an undefined format. So here, right, sensitivity cannot be defined. Why? Because this is alpha, right? Because this is exactly equals to 0, and I cannot divide anything by 0. Okay, then it becomes undefined, right? So obviously your option D will be correct here. Okay, none of the options are correct because sensitivity is not defined in this case, because this E of S of S is 0. So I'm dividing something by 0 which is undefined. Although here is some 0 multiplied, and you cannot do like this, right? You can cancel this 0. No, this we cannot do. This is not limits. Okay, so just be careful about that. Sensitivity in this case is undefined. So the maximum peak overshoot, right, is 40%. Okay, MPO, maximum peak overshoot, is 40%, that is 0.4, and the rise time is 1.932 seconds. T rise is 1.932 seconds. Okay, then determine the approximate closed loop transfer function for this system. What will be the approximate closed loop transfer function? So these two information are given, and if I want to write this in terms of zeta and omega, can I write this, right? You should remember this formula. The formula of maximum peak overshoot is e raised to power minus pi cot theta, where I know zeta is equals to cos of theta. What is theta? All those have been explained in the full course, so I will not explain it over here. This is equals to 0.4. Okay, this is equals to 0.4 So from here I will get the value of theta. What is my T rise formula? T rise formula, if you remember, it was supposed to be equals to e raised to pi minus theta divided by omega t. This was the formula for T rise. So I will find out theta from here, then I will put it here. This theta needs to be in radian, and I will get my omega d value as well. From here I will calculate omega n, and from here I can directly write the characteristics equation of a closed loop system. So from here I will calculate the theta, right? So it will be ln of 0.4. If I calculate this to be 0.4 ln, okay, and this divided by pi, then if I take the inverse, then if I take the tan inverse, theta is 73.74 degrees. Now if I want to convert this into radians, so in radians it will be 1.287. In radians this will be the theta value. Okay, so here I will put this value. I will put this value here. So I will get my omega d, okay, and zeta also. What is zeta? Zeta will be cos of this, right? So before that I want to calculate this one, because that is already present in my calculator. So T rise is 1.932. It is equals to pi minus 1.287 divided by omega d. So plus pi and then divided by 1.932. So omega d comes out to be 0.96. Okay, what about zeta? Zeta is cos of this, right? Zeta is 73.77 degrees. Cos of this, that is 0.279. okay, so can I write my omega n? Omega n is basically, what is my omega d? Omega d is omega n 1 minus zeta square. Okay, or omega n sin theta also you can write, whichever one you prefer. Okay, so this whole square plus 1 under root and into 0.96. okay, this almost comes out to be 1. Omega n almost comes out to be 1 radian per second. Okay, that is what this omega n is equals to. So from here I can make my characteristics equation. What will be characteristics equation? Standard characteristics equation of a second order transfer function is s square plus 2 zeta omega ns plus omega n square. So it is s square, zeta is 0.28, 0.28 into 2 is almost 0.56, s omega n is 1 equals to 0. This is the characteristic equation. So the denominator should be s square 0.56 plus 1. Only option D is correct, and it is standard also because the DC gain of this is 1. If at s equal to 0, the DC gain is 1. So option D is the correct answer of this question. Let's solve this question. A second order system with DC gain with unity DC gain and no zeros has a damping factor of zeta equals to 0.2 and an undamped natural frequency of omega n equals to 10. The system initially at rest is applied to a unit step, okay, step input at t equal to 0. The value of the response at t equal to 0.1 second. So simply, like, this is a standard formula based question. You should remember the standard response of a second order system. The standard response of a second order system with transfer function C of s by R of s like this, it is equals to omega n square divided by s square plus 2 zeta omega ns plus omega n square at s equal to 0. At s equal to 0 if I put, so it will be omega n by omega n, DC gain will be 1. Okay, this is the standard second order system. The response to this standard second order system is given as this, right? This I to tell you to remember. I have derived this in my full course, but obviously you don't have enough time to derive during the examination. It's better to remember this, right? So what is this? A is the amplitude of the step, okay, and K is the DC gain of the transfer function. So DC gain here is 1. A is also, it is we are applying, nothing is mentioned, so we are applying a unit step. Okay, so this will be 1 minus e raised to power zeta omega n by under root 1 minus zeta square. So what is zeta? Zeta they have given me. Zeta is equals to 0.2. Zeta equals to 0.2. So what is this? This is zeta omega n. Zeta omega n will be 2 only. It will be e raised to, sorry, this is t as well. Here there will be t. E raised to power minus 2t divided by 1 by 0.2 whole square. So 1, sorry, not 1 by 1 minus 0.2 whole square. Then take the under root of that. So it will be 0.98. Okay, into obviously sine of omega dt. What is omega d? Omega d is simply, either you can write omega n sine theta, or you can write omega n under root 1 minus zeta square. So omega n is 10 and 1 minus zeta square, right? Under root of this into 10. So this will be 9.8, right? This will be 9.8 radian per second. So it is 9 point, almost equals to 9.8 into t plus theta. What is theta? Theta is simply cos inverse of zeta, right? You can write here in radians, because this is also, the unit here is in radians, so you have to write here in radians. Okay, so zeta is 0.2, cos inverse of this, I will get the angle value. I will compute the radian. The radian will be into pi divided by 180. Okay, so this will be 1.37. 1.37. Okay, so this is the value, and what are they asking? They are asking me the output value of the response at t equals to 0.1. So I'll put here t equals to 0.1 and I will calculate this value. So if I put here t equals to 0.1, this is equals to 1 minus e raised to power minus 0.2 divided by 0.98 sine 0.98 plus 1.3. Remember, this is in 1.3 is in radians, correct? So if I do all this, right, plus 0.98, then sine of this, remember you have to change your calculator to radians, then calculate the sine of that angle, right? Else you will get a wrong answer. So change your calculator to radians, then calculate sine of this, because all this inside the sine is in radians. Don't make that mistake. Okay, divide by 0.98, this will be 0.72. Okay, so it comes out to be 1 minus 0.726 into e raised to power minus 2, right? So into 0.2 exponential and plus 1. So this almost comes out to be 0.4. Okay, the answer comes out to be 0.4. So like main thing is this formula, and this we have no choice but to remember, because you will not be able to derive this expression in the examination hall. You have to remember this formula. So answer will be 0.4. Let's solve this question. So we have to find out the damping factor of the circuit. Okay, for this given circuit, right? What will be the damping factor? First of all, you have to identify what is the transfer function. Transfer function is Vi over Vo. Okay, this is my transfer function. Now there are two ways to solve. Method one is with simple Laplace. Okay, simple Laplace. You write Vo of s by Vi of s. Okay, you find this one out. You find the transfer function, and from there you write the characteristics equation, the denominator, right? Denominator will be your characteristic equation. From there you find zeta. You compare with standard characteristic equation, that is s square plus 2 zeta omega ns plus omega n square. You compare these two, and then from here you will be able to find out the value of zeta, that is damping factor. What is the other way? Other way is a bit risky here. Other way is a bit risky, that I can apply superposition, but this will always not work. This will not work always. So if I apply superposition here, what I can do, right? I can convert this this voltage source into a current source, and this capacitor will be coming in parallel, right? So this will be some equivalent current source. I'm not writing it. This will be some equivalent current source. Okay, and this will be converted into a capacitor 1 by Cs, and I have a inductor here, and then I have a parallel resistor, and then I have again a capacitor. Now this, right, just becomes a standard circuit because this capacitor is of 25 pico. This is also 25 pico, right? Both are 25 picofarad. This is all 25 pico. This will always not work. Here it will work. Okay. And because we are able to convert this into a standard format, it is a standard parallel RLC circuit. If I convert this into current source, right, it becomes a standard parallel RLC circuit. So for a standard parallel RLC circuit, we know few results. That's why I'm doing this. L is how much? L is 2 microhenry. And my R is 100 ohms. So for a standard parallel second order circuit, I can convert this, right? Okay, the damping factor and natural frequency doesn't change. It remains same. So this will be like these two capacitors are here. So it will be 50 picofarad, and this will be inductance is 2 microhenry. This is resistor is 100 ohms. Okay, so for this standard type of circuit, right, we know what is my omega n. Omega n is simply 1 by under root LC. What is my zeta? Zeta parallel. If you remember zeta parallel, there was one relationship between zeta parallel, okay, and zeta series, right? If you remember it, great. If you don't, what we can do? So basically this, right, this was equals to 1 by 2 R under root C by L by C. Okay, if you remember it, great. If you don't, then you have to derive. The expression. This also I've told how you can derive, right? You can always derive this. That is very easy. You apply nodal here. You apply KCL, not nodal. Sorry, you apply KCL here at this node, right? Okay, so I will explain that as well. Just hold on a second. I will first calculate this. So this will be equals to I know what is R. R is 100. And what is my L? L is 2 micro. And what is my C? C here. This is the C, right? Not this C. The C in the modified circuit. C in the modified circuit is 50 picofarad. So it is 2 micro. That is 2 into 10 raised to the power minus 6 divided by 50 picofarad. That is 15 to 10 raised to the power minus 12. Okay. So this will be equals to zeta will be equals to 1 by 200 this will be 25 into 10 raised to power 6. Okay, so this ultimately comes out 10 cube divided by 5. So this is also 10 cube. It comes out to be 1. So your zeta here comes out to be 1. It is a critically damped system. Okay, so your zeta comes out to be 1 in this case. Now if you want to find out in this, right, 1 is your answer, that is done. 1 is your answer, that is done, right? But remember this, right, this formula is valid for zeta equals to 1, but if zeta is greater than, if your zeta comes out to be more than 1, right, this formula, all these formulas are not valid. If your zeta comes out to be more than 1, all these formula are not valid. Okay, that is for a overdamped system. Then the formula changes. Okay, then the damping, all those things changes. Zeta can only be, maximum value of zeta can only be 1. It cannot be more than that. Okay, so here if you want to write this down, right, I can apply a KCL at this node. If I apply KCL, it will be VO by this current. What is this current? This is S times L plus, I will assume this to be L, I will assume this to be C, I will assume this to be R, I will assume this to be C. Okay, so now here L, C, R are different, right? There L, C, R was different. This will be VO by LS divided by VO divided by R plus VO divided by 1 by CS plus VO minus VI divided by 1 by CS. Okay, I'm writing this KCL equation, right? VO minus VI 1 by CS equals to 0. You solve this, you will find VO over VI. You will find VO over VI. Then you will compare with standard characteristic equation, the denominator, and from there you will get the same results. But remember, your zeta will not be more than 1. Zeta here will be exactly equals to 1. This will be the answer of this question. Let's solve this question. The block diagram of a control system is shown below. The steady state error for a ramp input with a slope of 3 will be equals to what? Now this, right, is not a unity feedback system. But if you tend to remember the formulas, you know, your KV, velocity error coefficient, because for a ramp input you used to compute this. KV is limit as s tends to 0 SG of s. G of s, so it comes out to be 1 by s plus 6, 1 by s plus 6, right, as s tends to 0. So basically it comes out to be 1 by 6, right? And you know your steady state error is supposed to be 1 by kV for a ramp input, right? So it will be 6, and you will be wrong here. You will be wrong here. Okay, first of all, this is not a unit ramp input. This was derived for a unit ramp input. For any ramp input, right, you can multiply the slope with it, then you will get your kV, and then you can do the division by this, like a reciprocal of this, and then you will find it out. Okay, second thing is, this is not a unity feedback system. Okay, so then also you will not be able to apply the formula. So you have to go with the basics. In my full course I have taught how to calculate the steady state error for a non-unity feedback system. The steady state error for a non-unity feedback system, how do we calculate? We calculate when the system is ideal, when there is no problem. That means this equation, right, the error, this error should be equals to 0. That means when the system is ideal, that is R of s minus C of s into this value should be equals to 0. So when the C of s is some reference, because I need to compare with some reference. So C of s is the C reference of s. When everything is ideal, that means my error is 0. So from here I get the value of C reference of s. So this is the comparison that I will get. The comparison, I will compare my C of s with the reference of C of s, that is R of s divided by H of s. This is my reference C of s, with which I will compare. But in actual case, what is my actual output? Actual output is R of s into T of s. There can be some disturbance in the transfer function, due to which the transfer function is changing, and due to which my actual output is not exactly equals to the reference output. I will compare these two. The error will be actually equals to C reference minus C actual. This is the formula for error in non-unity feedback system. So if I compare my error E of s in Laplace domain, it comes out to be R of s by H of s minus T of s, or it comes out to be not T of s, sorry, into T of s into R of s. So if I take the R of s common, okay, this will be 1 by H of s minus T of s. Now we need to solve it. What is my transfer function when it is a non-unity feedback system? It is G plus 1 plus GH. So what is G? G here is 1 by S into S plus 6. 1 by S into S plus 6, and it is 1 plus 1 into G of H of S. H of S is S plus 2 divided by S plus 1. It is S plus 2 divided by, okay, just hold on. S plus 2 divided by S plus 1 into 1 divided by S into S plus 6. Okay, so this is equals to 1 divided by S plus 1 into S into S plus 6 plus S plus 2, and in the numerator as well I will get S plus 1, correct, because S into S plus 6 will get cancelled. S plus 1 will be there in the numerator as well. Okay, so this is the case actually. What we could have done, right, we could have directly calculated this expression actually, instead of doing all this, right, we could have actually directly calculated this. So this, right, will be equals to R of s into 1 by H of s, 1 by H minus G by 1 plus GH. Okay, so if I just want to do something, right, so if I want to calculate this, this comes out to be R of s into 1 plus GH minus G into H divided by h into 1 plus gh. Okay, and what is my steady state error? Steady state error will be limit as s tends to 0 s into the r of s. What is r of s? R of s, remember, it is a ramp input with a slope of 3. It is a ramp input with a slope of 3. So it will be 3 by s square into 1 divided by h. What is h? H is this value, right? Although I have computed the transfer function, actually this would have been the better approach. So h is this. H is this. So it is s plus 2 divided by s plus 1 into 1 plus g of h of s, right? 1 plus g of h of s. 1 plus g of h of s is this thing only. Okay. Into 1 plus this thing. Okay, we'll copy this. So now if I want to rewrite this, my steady state error is 3 by s, and at the numerator what do I get? At the numerator it will be 1 minus g of s will get automatically cancelled. So this is s plus 2, right? So this whole thing will get multiplied, right? This whole thing will get multiplied, and this also will go at the numerator. So it is s plus 1 into s plus 6, okay, divided by s plus 2 into s, just hold on, s into s plus 6 into s plus 1 plus s plus 2. Okay, this is your final result. And obviously I'm applying the final value theorem, assuming that like they are asking in NAT. Okay, so obviously system will be stable, then only I will get some finite steady state error. So as assumption is system is stable. Okay, so this will be 3 by like I also forgot to write limit as s tends to 0. So what do I see? Here I have s, here I have s. So this s gets cancelled. So this will be equals to 3 into 0 plus 1 into 0 plus 6 divided by 0 plus 2. This whole thing will be 0 plus 0 plus 2. Okay, so ultimately it comes out to be 3 into 6 divided by 4. So it is 1.5 into 3, that is 4.5. 4.5 will be your correct answer for this question. Let's solve this question. The control system is shown in the figure below. The delay time in seconds will be equals to what? So control system is shown. We have to find out the delay time. What is a delay time? Delay time for a standard second order system. Delay time for a standard second order system is given by this formula, right? The formula is TD is equals to 1.1 plus 0.7 zeta divided by omega n. Okay, so this is what your delay time is given with this formula. I hope you remember. I have told you trick as well how to remember this formula and the rise time as well. Okay, so for that I will need this zeta and omega n. So for that I will need to find out the characteristics equation of this block diagram. But I need to solve this, right? I need to solve this. So here actually this R is missing. This should also be 1 ohm. Okay, here this should be 1 ohm. This R is missing. This will be equals to 1 ohm here. Okay, this will be equals to 1 kilo ohm. Okay, everything is 1 kilo ohm. So we have to solve this circuit. Okay, so what is the output here? What is the output here? This input like let me find the transfer function of this block, right? Let me find the transfer function of this block. So if I want to find the transfer function of this block, I will copy this block. I will copy this block and paste it over here. Okay, so I am giving some input here x. If I am giving some input here x, this is like virtual ground concept is valid. So this will be 0. So this will be 0 minus x divided by 1 should be equals to 0. Let me name this output as something z for now. Okay, so this will be plus 0 minus z divided by 1 equals to 0. So your z is simply equals to minus of x. Okay, z is equals to minus of x. And what about here? If I apply the same virtual count concept here as well, this will be my output, right? Let me name the output as y. So again, 0 minus z divided by 1, I'm just simply applying the KCL, plus 0 minus y divided by this impedance. What is this impedance? This is R. I will write R for now, divided by 1 by C of S equals to 0. Okay, so this comes out to be your y comes out to be minus of z into R divided by C of S. Okay, and what is z? Z is minus of x, right? So it comes out, so your y by x, right, the transfer function comes out to be R plus 1 by CS. This is the transfer function of that whole block. Okay, of that whole block, this is the transfer function. Okay, now okay, this is fine. R divided by 1 plus CS, right? Everything whatever I'm done is correct. That is what I'm just checking if I'm correct or not. That should be on the top. This should be here one. Yeah, this is fine. So everything is correct. Yeah, so what I wanted to write, I already know the transfer function of this, right? So this is the controller transfer function, this is the plant transfer function. So total my G will be GC of S into GP of S. Okay, so this will be equals to GC of S is this controller transfer function, that is RCS plus 1 divided by CS. This is the controller transfer function. And what is R into C? R into C is simply 1, right? R into C is simply 1. Milli times kilo is simply 1. So this will come out to be 1. Okay. And C is 1 millifarad. Okay, C is 1 millifarad. I will keep the C for now. I will keep the C here for now. The reason being, I don't want to write the units as of now. R into C product was simply 1. That's why I replaced R into C with 1. Okay, into the plant transfer function. Plant transfer function is S plus 1, S plus 0.5. So this will be 1 divided by S plus 1 into S plus 1 into S plus 0.5. Okay, so this is equals to 1 by CS into S plus 0.5. So this is my closed loop transfer function. Okay, this is my closed loop transfer function. Now I will solve this. I will find the this is my open loop transfer function. I will find the closed loop transfer function. Closed loop transfer function will simply be G upon 1 plus G of S, because it is a unity feedback system. So this becomes like 1 by C can be written here, right? 1 by C can be written here. This is equals to 1 by C into 1 divided by S into S plus 0.5 plus 1. Okay. So from here I will be able to write my characteristics equation. What is the characteristic equation? Characteristic equation is S square plus 0.5S plus 1 equals to 0, and I can compare it with my standard second order characteristics equation. Okay, so according to standard second order equation, this will be omega n square, right? This will be omega n square equal to 0. So omega n comes out to be 1. So 2 zeta omega n equals to 0.5. So my zeta comes out to be 0.25. This is what your zeta comes out to be. And your omega n is this. And what do I need? I need these two values, zeta and omega n, right? To find out the delay time. So my delay time TD will be 1 plus 0.7 into zeta, that is 0.25 divided by omega n. Omega n is radian per second. This is in radian per second, right? So automatically this will be in second. Whatever the unit will be, this will be in second. So this value will be will come out to be 0.7 into 0.25 plus 1. So it is 1.175 seconds. So this will be your answer because they have asked in seconds. What is that delay time? Delay time will be 1.175. 1.175. This will be your answer of the question. Let's solve this question. The closed loop control system as shown in the block diagram below is expected to track a DC reference perfectly. Which of the following arguments will have to hold for the open loop transfer function g of h of s or g of s as here? It should have at least one pole at the origin, it should have at least one zero at the origin, should have pair of imaginary poles, or no condition to track the DC perfectly. So in these type of cases, right, what is DC? DC is basically a step input, right? DC means basically a step input. What is the amplitude of the input? I don't know. Okay, this I have taught in my full course. Okay, if you are ever giving a step input to a standard unity feedback, negative unity feedback system, you need to have at least one pole at the origin. The type must be 1 of the open loop system. Why? Because your error, right? Error E of s is simply R of s minus C of s, and ultimately your value will come out to be like your steady state error, right? It has to be 0. This has to be 0. That means my limit, I will apply the final value theorem, s into R of s 1 minus T of s. Okay, so this is equals to basically R of s is 1 by s, so it is 1 minus T of s. It is 1 minus T of s. So this transfer function, right, you will find it out whenever you will derive. Transfer function is what? Transfer function is g of s upon 1 plus g of s. You choose any transfer function which has a pole at the origin, just at least one pole at the origin, the error will always come out to be 0. This expression will always come out to be 0 for a unit step input. Okay, so the answer here will be option A. G of s must have at least one pole at the origin. Let's solve this question. So the closed loop transfer function of a control system is given as below, right? C by R is this. This is just a standard second order transfer function. Okay, the location of poles of the systems S1 and S2 are shown here. These are the location of poles. From the location of poles, I can observe they are complex conjugate poles. If they are complex conjugate poles, that means my system will be underdamped. For both S1 and S2, both are underdamped. Okay, so if alpha square plus beta square equals to 5, then which of the following statements is correct about system S2? So alpha square, right? Alpha square plus beta square. Alpha square plus beta is this. Square is 5. So what can be inferred? So if you remember, what was this alpha for a second order standard second order system? This alpha also minus alpha is also equated as minus zeta omega n. If you remember the poles of a standard second order system, the real part is minus zeta omega n. How does it come? If you remember it, the standard second order system, right, has this as its characteristics equation. Now if I want to compute the poles of this, what are the poles? I can apply the Sridhar-Acharya formula. Sridhar-Acharya formula is minus 2 zeta omega n plus minus b square minus 4. So I don't care about this because this will come out to be something imaginary. I just only care about this because I'm only discussing about the real part. If I'm discussing about the real part, so I will discuss, right, I will care about the imaginary part as well because beta is also there. So this will be equals to b square. B square is zeta omega n whole square minus 4ac. 4ac is 4 into omega n square. Okay, divided by 2a. So this comes out to be minus zeta omega n, which is my what? Which is my minus alpha. Okay, plus minus the imaginary part here, right? Zeta is supposed to be less than 1. If zeta is supposed to be less than 1, so it will be b square minus 4ac. Sorry, b square is 2 zeta omega n, right? So this will be 2 zeta whole square. So ultimately what will happen, it here also 2 will come outside. Ultimately this will be j into under root j into omega n under root 1 minus zeta square. Okay, because my zeta is less than 1, obviously this will be a complex number. Zeta will be less than 1, this will be a complex number. So I can compare this with beta. So this is my beta basically. So this we already know. If you tend to forget this, I have told you. Okay, so what is alpha square plus beta square? If you compute alpha square plus beta square, you will get it is equals to omega n whole square. So alpha square plus beta square equals to omega n whole square equals to 5, that is given in the question. So it will be equals to 5. So omega n will be equals to under root 5. Now omega n is under root 5 and zeta omega n is supposed to be Have they given? No. Zeta omega n they have not given me. Okay, I cannot comment about anything else. Now one more thing is imminent from the figure. The angle theta, right, is same. The angle theta of this system S1 and S2 are same. So if the angles are same, that means what? The ratio of height and base of the two triangles are same. They are similar triangles, or you can write the tan theta. Tan theta of S1 will be this 1 upon 1, that is 45. Tan theta of S2 will also be 45. So theta is 45 from system S1. I can identify from S1, right? Tan theta is equals to height upon base. Height is, what is the height of this triangle? It is 1, right? What is the base? Is 1. Okay, so 1 upon 1, that is 45 degrees. So tan 45 is 1, so theta is equals to 45 degrees. So this also will be same. The height and the base also will, here this triangle also will be same. For system 2, S2 will also be same. So my alpha will be equals to beta. If my alpha is equals to beta, that means alpha square plus beta square equals to 5. That means alpha square equals to 5 by 2, or alpha equals to under root 5 by 2. Okay, I know what is alpha. Alpha is equals to zeta omega n. Omega n is under root 5. So zeta comes out to be 1 by under root 2. Zeta is 1 by under root 2. But what are they asking? They are asking me the settling time. What is the settling time? Settling time is basically 4 upon zeta omega n, or the real part of the pole, right? Real part of the pole is alpha itself, so it is 4 upon alpha. So alpha is what? Alpha is under root 5 by 2. Okay, so it will be equals to under root 5 into under root 2. So if I calculate this value, 5 divided by 2 under root into 4, so it will be 2.53. okay, this is my settling time. Is it present in the options? No, it is 1.13. okay, it is 1.13. so of course it is not the correct settling time that is present, so this will not be the correct answer here. Let me check the other options. Okay, the peak time will become 0.89 seconds. Peak time will become 0.89 seconds. Okay, sorry, one mistake I have made. Sorry, this is under root alpha square plus beta square. Sorry, this is under root alpha square plus beta square. So under root alpha square plus beta square, right? This will be equals to 5 square basically. So omega n will be equals to 5. That is my mistake. That is where I was going wrong. So here, right, this will be equals to 5 square by 2. So this will be 5 by under root 2, because I thought option 1 was supposed to be the correct answer. So from here, right, zeta is 1 by root 2, that will not change. This will be 4 by 5 into under root 2. Okay, this will be 4 by 5 into under root 2. So if I multiply 4 by 5 into under root 2, it comes out to be 1.13, which is correct. Okay, I made a small mistake here. Comes out to be 1.13 seconds. Okay, so 1.13 second is option A. Option A is correct. So what are the other correct options? Peak time is 0.89 seconds. So peak time, what is the peak time? Peak time, if you remember, it is equals to pi upon omega d. What is omega d? Omega d is simply pi upon omega n sine theta, or it is omega n into 1 minus under root zeta square. Whichever one you prefer, you can write. I will write sine theta. Omega n is 5. Okay, sine theta is sine 45, that is 1 by root 2. So it is root 2. So it is pi by 5 this time. Pi divided by 5 into root 2. Equals to 0.89 seconds, which is also present in the option B. So this is also correct answer. This is also one of the correct options. Let me check the last and final option. Peak value of response for 2 UT is 2.08. Peak value of response for 2 UT is 2.08. What is the peak value of response? If you remember the peak value of response, right? What is the peak overshoot? If you remember, the peak overshoot was supposed to be e raised to power minus pi cot theta. Okay. And the peak value of response was AK 1 plus e raised to power minus pi cot theta. This was the overshoot, and this is the total maximum peak response, right? Maximum peak response of the output. Okay. If you remember very well, if you don't remember, then you have to go and study from my notes. Okay. A is what? Like, it may feel like I'm telling you formulas, but I have derived everything. I have told you how to remember as well, because few things you have to mug up, but I have told you the concept behind all this. Okay, so it's not like you're mugging up blindly. I have told you I've derived everything from scratch in the full course. So A is the amplitude of the step input and K is the DC gain of the transfer function. So in our case, they're telling me amplitude of step input is 2 and DC gain here, right? DC gain means in the transfer function, if I put S equal to 0, what is the transfer function? Transfer function is K. Okay, actually they have not told us what is K. That is one thing is there. Actually K should be equals to 1. Okay, K should be equals to 1. I will put the condition K is equals to 1 in the question. K is equals to 1. So if K is equals to 1, then this becomes A is 2, right? A is 2, K is 1. So this becomes my peak of the output. It will be 2 into 1 plus e raised to power minus pi cot theta. Theta is 45. Theta is 45. It will be simply e raised to power minus pi. Okay. So this will come out to be pi. Theta is 45. So cot theta is also 1. Exponential plus 1 into 2.086. It comes out to be 2.086, which is also present in option C. So option C is also correct. Delay time will become 0.2 seconds. So what is the formula for delay time? All this I have told you how to remember, derived as well. Delay time is pi minus, not pi, 1 plus 0.7 for an underdamped system, 0.7 into zeta divided by omega n. Okay, so here zeta is 1 by under 2, so it is 0.707 into 0.7 plus 1, omega n is simply 5, right? So it also comes out to be 0.29898. Okay, everything is almost correct. Everything is also correct. This is also equal to 0.3 seconds. Okay, because omega n is 5. So okay, this is 0.2 seconds, but I got my delay time to be 0.3 seconds. So this is the wrong option. This will not be the correct answer. So A, B, C will be the correct answer of this question.